Hi and welcome. This is the 15th video from Darton College's Flip Learning series on forces and motion. This video is on gravitational potential energy. My name is Mr. Clee. So the aim of this video is that by the end of it you should be able to describe the factors that affect the amount of gravitational potential energy that an object has. You should be able to use the equation, which is GPE times mass, GPE equals mass times gravitational field strength times height above the ground. You should also be able to describe how GPE and KE, which is kinetic energy, changes in a falling object, linking this to the equation. And you should also be able to explain why kinetic energy doesn't increase at terminal velocity, but gravitational potential energy continues to decrease. Right, firstly, the amount of gravitational potential energy that an object has depends on two things. It depends on the height above the ground, and it also depends on the mass of the object that's being moved. The heavier the object and the higher the object, the more potential energy it has. Gravitational potential energy is the amount of potential to do work that something has when it's higher up. So the heavier it is, the higher it is, the more of that it has. So this is how we express that in an equation. We basically say that the mass of the object times by gravity times by height gives you GPE, or mgh. Another way of writing that is just the weight times the height. So if we've got an object, a person, of 60 kilograms and he's on top of a cliff, 50 meters high, what's GPE? Well, the way that we do this is we do 60 for his mass times by gravity, which is 10, times by 50. That leads to an answer of 30,000 joules of gravitational potential energy at the top of the cliff. Next thing we need to think about is how gravitational potential energy changes as an object falls. If we consider three stages in a tin of paint's journey from the top here to the floor. If you think about the equation, if you do mgh here, here and here, at all 3 points, gravity will not change. The mass of the object does not change, but the height changes. The height is lower as you are further down, further through the fall. So the object's GPE, the amount of gravitational potential energy, is lower the further down you are. So at the top, the gravitational potential energy is the most, and it decreases as it falls. Because we also know that objects accelerate due to gravity, and we know that the equation for kinetic energy is a half times mass times velocity squared, that object that's accelerating, that's getting faster as it falls down to Earth, will be increasing the amount of kinetic energy it has because its velocity increases. So as the velocity increases, the kinetic energy also increases. So if we have a situation here where we've got 30 joules of GPE there, then at the end, when the tin, or just before the tin hits the floor, we have 30 joules of KE, of kinetic energy. So what's happening is the gravitational potential energy is being converted into kinetic energy. As it falls, gravitational potential energy goes down and kinetic energy increases. All of the energy, all of the GPE, is transferred from gravitational potential energy to kinetic energy. You can see that in the ball here. As the ball falls, the gravitational potential energy starts off at 200, and as it's falling halfway down, it's still got some GPE left, but some of it's been transferred to kinetic energy, and just as it hits the ground, all of that GPE, the 200 joules, has been converted into kinetic energy. There is one more thing that we need to consider. We know that gravitational potential energy is equal to mass times gravity times height. So this parachutist here, as he falls to Earth, because height is decreasing, the amount of kinetic energy that he has, the amount of gravitational potential energy that he has, will decrease. But we have a problem, because we already know that at terminal velocity, velocity does not increase. So at terminal velocity, because velocity is not changing, the kinetic energy will be the same all the way down. So we've got gravitational potential energy decreasing, but kinetic energy not increasing. So where is the gravitational potential energy going? And that's simply transferred as thermal energy and transferred to the surroundings. So that all that energy, when you're travelling really quickly, goes in heating things up and making noise and is just dissipated through the environment. It's hard to show energy, but it's kind of just like it just dissipates off into the environment somewhere. So in summary, the amount of gravitational potential energy an object has depends on its mass, its height above the ground, and gravity. We measure gravitational potential energy in joules, and for example, a mass of 10 kilograms at 2 meters would have a store of 200 joules of gravitational potential energy. This GPE is converted to KE as an object falls, with GPE highest at the top, kinetic energy highest at the bottom of a fall, and then the complicated bit at the end, as at terminal velocity, GPE is converted into heat as friction rather than into kinetic energy as speed, because the velocity is staying the same. Thank you very much for watching. My name is Mr. Clee. This video is for Thursday the 22nd of May. Please bring your evidence to the lesson.